Yes, this is Dr. Emmanuel Rich. Straight to the point. This is the second example of an over refraction question that you can meet in your optometry licensing exam. And I've solved one question previously on the background explanatory video I made. Now, this is a second example with different options, different values. So let's go straight to solving it. And if you don't understand how I applied the knowledge I applied here, go back to watch the full video of the previous solution. Thank you. All right, so in this question here, we are giving our prescription to be plus 3.00 minus 2.50, axis 180, and we are giving our keratometry readings of 43.00 at 90 meridian and 40.50 at 180 meridian. So this is the flatter K, because it's the one that has the lower value. Then the contact lens we are given is a minus 1.00 ds with a radius of curvature, the base curve, so the BC of 8.33 millimeters. So they asked, the question was, what is the expected over refraction? So let's continue. All right, so if you've been following me before, if you've watched the previous video, you will know some things by now. So but let's keep on going. So our formula for refraction is, for me, this is my formula. I derived it when I was preparing for exam, and I've given it to a lot of people to use it. It's so good. So over refraction is equals to the refraction result they gave you, especially in this case, is this spherical component, or the spherical component of the refraction result, then minus the contact lens prescription they gave you in bracket, then plus the tear lens. I wish I can find a question that the tear lens has a value so that you will see how it works. So for us to get this, it has already been there. We have our refraction results, we have our contact lens. So the only thing we don't know how to get it is the tear lens. And in this question, we were giving a keratometry reading. So I said for us to get the tear lens power, we have to subtract the flatter K minus the base curve. We were given the base curve, but the base curve we were given is in millimeters. So we have to convert our base curve to diopters, and for us to do it, it will be this constant, this refractive index constant over the BC in millimeter. That's when we can convert it to diopters. So if we convert our base curve to diopters, then we'll be able to subtract it from the flatter K, and we know our flatter K here is the 40.50. So let's convert our BC to diopters. So BC is equals to 337.5 over 8.33 millimeter. Can just remove this 8.33. So this will also give us 40.50 approximately. So it was 40.51, but it's closest to 40.50. So therefore our flatter meridian, so for us to get our tear lens value, this shows that the contact lens and the eye align very well with the flatter meridian, because this value is the same with the flattest meridian. So the flatter meridian is 40.50 on the 180 meridian minus 40.50 minus 40.50. So our tail length here is equals to 0. So we don't have anything to worry about the tail length because our base curve is well aligned to the flattest meridian. Okay, let's go. So since we've seen what our tail length is, the next thing to consider, from the previous video I told you that the type of lens you were given should be looked into, and most of the times they always give you a rigid lens. Why? Because a rigid lens takes care of corneal toricity up to, let's say, up to minus 3.00. So anything less than this, you can still use rigid contact lens to take care of it. Okay, so let's keep going. All right, so since that has been taken care of, so let's go back to our formula again. Over refraction equals to S spectacle prescription, or the refraction result, minus, in brackets, the contact lens plus the tail length. So like I said, this cylindrical component of this prescription has been taken care of, so this will give us plus 3.00 minus, in brackets, our contact lens is minus 4. Sorry, and this question is minus 1.00 plus our tail length is 0. Okay, so we continue. So this will give us, if we open this bracket, 3.00, this plus this is still 1. So when we open this bracket, it will be plus 1.00. So minus times minus is plus. So this is it. So our over refraction in this question, will now be equals to plus 3 plus 1 is plus 4.00 ds. So this is the answer. So look for this on the option. I think the option there is B. So that is our expected over refraction. To explain this in a simple term, okay, for us to understand again, a patient has a prescription that is up to plus 3.00. So an eye that wears plus 3 means that eye is already a minus 3i. For you to give a patient a plus 3 as a correction, that means the eye was originally a minus 3i. That was why you used plus 3 to correct the eye. If an eye is, let's say, minus 2i, it shows that the eye was initially a plus 2i. Then you used a minus 2 to correct the eye. So in this case, a patient's eye was initially a minus 3i, and after refraction we used plus 3 to neutralize the eye. So the patient got 6s with this. Okay, then when you add a minus 1 ds on this eye, the total value you'll be having on that eye will be minus 4. So when an eye is minus 3 and you put a minus 1 contact lens on that same eye, the total power of that eye at that moment will be minus 4. So for you to be able to neutralize this minus 4, the total over refraction you will now have in this case will be plus 4 diopters. This is what actually happened here. All these stories here, this is actually what happened. So this eye initially is minus 3, you did refraction, and refraction shows +3 spherical component. Then you used you did not give that +3, you ended up giving -1 on that same eye. So that means you increased the minus power of the eye by 4. So for you to correct that eye, in that case, you need a +4 lens to correct the eye. So this is what happened in this case. So that is it. And most of the times, the reason why in this exam they always give keratometry reading, you use keratometry reading to do two things. First is to check if the astigmatism you are having is cornea or residual or internal. So cornea astigmatism, you confirm that you have cornea astigmatism when if you subtract your once you subtract your care reading and it was given the same value as the value on your prescription, as the seal value on your prescription, then the astigmatism is of cornea. But if the care reading was not given up to the amount of astigmatism on the prescription, that means you have a residual astigmatism. So in this case, when you minus 40.43 minus 40.50, it still gives you 250 minus 250. That shows that this astigmatism here is completely a cornea astigmatism, and a rigid contact lens will be able to take care of it. So I'm going further. So I think we've actually understood what I did here. So this is the answer for this question. Thank you.